So this is Momentum FRQ Practice from the Physics Honors Unit 5 curriculum. Here are some important formulas to note. Momentum, know that the variable used for momentum is P. We have kinetic energy, gravitational potential energy. I know these formulas were from last unit, but you will be needing them in this FRQ. And then the big one, conservation of momentum formula. This is probably the most important one you will be using in this FRQ. It is basically to state or to calculate the velocities of an object before and after it collides with something else. So I'll be showing you how to do all this later in the presentation. Make sure you know these formulas for the test, and you should be good to go. So here's our scenario. We have a ballistic pendulum where a marble is fired at a block. The marble as 0.5 kilograms and the block is 4 kilograms. The marble's initial velocity is 10 meters per second and the block is stationary. Assuming that the marble connects with the block on impact, the two will spring together in a pendulum-like formation. It will go back and forth because this is a closed system. Remember that everything we do in honors physics is a closed system where no other forces are acting upon the objects. So obviously we want to annotate the diagram first, know what's going on, know our numbers, so we know what to plug into the formulas. And let's move into part A. So for part A, we want to calculate the momentum before the collision. So obviously we have all our numbers. And feel free to pause the video at times to try and solve these questions on your own before I move on to the explanation. It'll be very beneficial for you and the upcoming exam. And yeah, so let's move on. This one's a fairly simple question. We just need to figure out the momentum using the momentum formula. We have all the numbers, plug them in, solve, and remember to use kgm over s for momentum. This is the standard unit for momentum in our physics curriculum. There's a bunch of algebra to prove why this is true. I will not be getting into that because this is just the FRQ practice, but if you're really interested, you can look it up, figure it out, and yeah, just understand the basic concept behind this momentum. So for part B, we want to use the information provided, calculate the kinetic energy of the marble before the collision. So this, again, is a fairly simple question. We just need to use the kinetic energy formula. Obviously, it's 1/2 mv squared. We have all our numbers, plug them in, and we should get 25 joules. Remember that the unit for energy is joules from last unit. So just keep that in mind, and you should be good for the first 2 questions on the exam. Part C, this is where it gets more difficult, where you need to start using much more complex formulas like the conservation of momentum formula. So we have to calculate the speed of the marble and the block. Remember, the marble and the block have a combined mass of 4.5 kilograms. So your new mass for this portion of the FRQ will be 4.5 kilograms. And you need to calculate the speed of the marble after the collision. And again, assuming they both stick together on impact, which means that their total mass will be 4.5 kilograms. So here's our explanation. It looks like a lot, but it really isn't once you get the hang of it. So we need to use the conservation of momentum formula. So this is the formula, m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. These subscripts just tell us which mass and which velocity we're using, whether it's from the marble or the block. The prime, the little quotation marks, apostrophes, whatever you'd like to call them up here, these represent the after velocity after the collision occurs. So you can think of this like velocity naught and then the new velocity. So initial velocity, new velocity. This is how you can think of this, just to clarify. So this formula states that the momentum of the block and the marble at the beginning, before they collided, is equivalent to the velocity of the block and the marble after the collision. So through this formula, we can conclude that the velocity of the block and the marble in this portion of the equation will be the same because they are connected. I can go back to the previous slide. The velocity of the block and the marble, once connected and swinging up and down, will be the same. This is key to solving this problem. So we can conclude that V2 prime plus V1 prime is the same thing. These two variables are the same. This is the concept that will solve your problem. So, since the total velocity after the collision will be the same between both objects, we can safely conclude that V1 prime and V2 prime will be the same. So we need to isolate this variable, solve for it, so we can figure out the velocity after the collision. So we can cancel this out because it's 0. The block was at rest in the first portion, so we can completely cancel this out, and we get m1v1 equals m1v prime plus m2v prime. We cancel out the subscripts because v prime is equal. We factor the v prime, m1v1 equals m1 plus m2 times v prime. Bring m1 plus m2 to the other side, and now you have your formula. Up here is your formula for solving the velocity of the block and the marble after collision. This is all the algebra you will need to know for the exam. Please make sure you understand this concept. I'm sure I explained it well enough. If you have any questions, you can always come talk to me in school. I can see what I can do, or you can talk to the physics teachers, see how they can help you. They're always offering extra help. So we plug in our numbers. Remember that the mass is 0.5 plus 4 over here, and you answer 1.4. Remember your units for velocity is meters per second, and make sure you know how to use your calculator correctly. It's worse when you know how to do all the algebra, you have the correct formula, and you just plug in the numbers into your calculator incorrectly. Please double check this step multiple times because this is probably where most of the points are coming from on the FRQ. This is where most of your work is shown, and most points will be awarded if you know how to do this correctly. So now we can move on to part D. We need to figure out the maximum kinetic energy of the block-marble pair. So we want to know the kinetic energy of the block and the marble when they are swinging in unison. So the formula we want to use is KE equals 1/2 mv squared. We obviously found the velocity from before. We know that our total mass combined of the marble and the block is 4.5. We plug in our numbers, solve, and we get 4.41 joules. Part E, what is the maximum GPE of the block-marble pair? So this is a fairly simple question. We have our numbers, but if we remember the law of conservation of energy from last unit, we can conclude that the GPE in this situation will be exactly the same as the kinetic energy because of the law of conservation of energy. So here's the explanation. We just use the law of conservation of energy. The GPE will be the same as the total KE because this is a closed system. No energy is being transferred into other unnecessary forms. There will be 100% conversion of energy between GPE and KE. Part F, we need to find the maximum height of the block-marble pair. So this is, again, one of the more difficult sides to this FRQ. We need to figure out how high this block-marble pair will reach when and after the collision. So we need to figure out what formula to use. Obviously, it will be GPE. It's the only formula that deals with height. We want to solve for height, isolate h, and we plug in our numbers, we solve, and of course, we need to remember that the block-marble pairs' total mass is 4.5 kilograms. This is essential to solving the latter portion of the FRQ. You need to know that the combined masses will be 4.5 kilograms. Specific to this question, but it should be different on your FRQ on the exam. Remember to answer in meters. This is the standard unit for height in physics honors. And make sure you understand this concept, doing the algebra, making sure you know what numbers to plug in, and make sure you plug into your calculator correctly. So in conclusion, you learned how to correctly show your work for each part of a momentum FRQ from Physics Honors Unit 5. So I encourage you to use the information you learned today and apply it to the upcoming exam. Remember your units, formulas. We might have a formula sheet provided. And remember your scientific laws, like law of conservation of energy and law of conservation of momentum. These will be key to understanding what the FRQ is talking about. Remember your units, joules, kgm over s, which is the standard unit for momentum. And remember the formulas you will need to use. You know how to derive them, solve for certain variables, and you should be set for the upcoming exam. I wish you the best of luck, and I hope you took something important from today's lesson. Thank you.